Then the important part of the chapter is to be able to calculate moments and be able to apply principle of moments. So you can calculate moment by using this definition here, or rather this one. They say the moment is given by the product of the force F and the perpendicular distance from the line of action. That means where the force is to the pivot. So moment is force times perpendicular distance. So moment has a unit of Newton meters. Sometimes you may see Newton centimeters. But if there is, if there is no requirement by the question, I would suggest we convert everything to Newton and meters so that it doesn't cause any confusion later. Then force has an SI unit of newtons, and then distance will be in meters. So if you look at the diagram on the side, you will see where the pivot is and where is the distance and where is the force. And notice the force, right, and the distance is really perpendicular. On paper, you can actually draw it out, the right angle. So the moment, because of the formula, you can safely say that moments is dependent on the force, the amount of force that's being applied, or how far away is the force from the pivot. So in general, if you have a fixed distance, then a greater force means greater moment. Then if it's a fixed force, then a greater perpendicular distance, that means it's greater moment. So the reverse for these two cases is also true. So I have something like this. We have 30 centimeters and then we apply a force of 50 newtons. And another one, which is 60 centimeters and 50 newtons. Which one has the higher moment?
That's 60 centimeters.
Yeah. So then I have another case where you have 30 centimeters, 50 newtons, and 30 centimeters again, then 100 newton. Who has a greater moment?
Newton. 100 Newton.
Okay, let's see. So there are two types of moments. One is clockwise moment, and the other one is anti-clockwise moment. Do you have problem identifying which one is a clockwise moment and which one is an anti-clockwise moment? No. Okay. So in general, we can just apply a force here and cause the object to turn. When it turns in clockwise direction, that means the moment is clockwise. Then you do the reverse. You apply a force here, hold this, then the object goes anti-clockwise. That means the moment is anti-clockwise. So, okay, what happens if, okay, in this case right now, I have two forces and two perpendicular distance. So what can I do? Do I?
Must add the force together, then add the distance. Then force times distance.
No. What you do is you find each pair first. So you find the moment. Okay, let's say you find this moment, the moment caused by this pair, and then you find the moment caused by the other pair here. So what you do is, okay, is this clockwise movements or anti-clockwise movement?
Anti-clockwise.
Why is it anti-clockwise movement?
It's clockwise.
Okay, so it's clockwise because the force here will cause this to go this way. And this one is also clockwise because the same happens. So you will find this moment first. I call this moment number 1, and then this one is moment number 2. So moment 1 is equals to force times distance. So it's force 1 times distance 1. Then moment number 2 is force 2 times distance 2. So you will have total moments equals to F1 times D1 plus F2 times D2. So this is what you have. This is how you find the total moment. You find each individual and then you add up. Okay, now your turn. What is the total clockwise moment?
9.
What's the working?
5 times 10 plus 2 times 20.
Total moments equals to 2 times 20 plus 5 times 10, 40 plus 50, 90. What is the units?
Meters.
Newton meter. Okay. Okay, question 2, part A. Explain why it is easier to push a door open as far away from its hinge as possible. That means they're asking you why is it easier to apply the force here and open the door than when it's on this side?
Because applying the
So
pushing the door from the doorknob, it is further away from the pivot.
How are you going
And
to write it?
therefore requires the least amount of force. If you push the door from closer to the pivot, it will require more force.
Why? Are you missing out on something? I know it's easier to push at the end and not push in the middle. Then you require less force when you push at the doorknob, which is very far away from the hinge. But why? Is there a magic word to it?
Because it will be heavier
What's
and
heavy?
closer to the pivot, the door will be heavier.
Door behavior. But the door has always been the same. You never cut any portions of the door. So the mass and the weight of the door should be exactly the same.
Because there's nothing for you to hold on to when you're pushing the door.
I can put a doorknob there, like I draw a green color doorknob there. Why is it more difficult there? When structured question, I'll keep asking you why and why and why. And every why you give me a certain answer that will make your answer more complete. Why? So it's a moment step.
The other perpendicular distance from the turning point, the other the turning step
Yeah.
will be.
Yes. So there is a longer perpendicular distance from the hinge, so it will cause a greater movement. Then it will be easier to push the door open without having to exert a lot of force. Something like that. I'll let you try it first. 4, 3, 5 plus 2. 25 newtons times distance. Distance is 40. Yeah. Be careful of limits. Force times this. Okay.